so sad. I'm really sorry, Block C video. You should probably start with the Block A video for this. Wait, what block are you guys? This is Block A. I'm sorry, Block A. You should start with the Block C video because I started this one late. My apologies. So, let's look back to where we were. Once we've identified that this is in fact negative, we do biggest minus smallest, and then it's going to have, that looks like division. And then our result is just, we just quote it as being negative. So now I'm going to make this 12.41 minus 8.23. I know it's backwards, but we accounted for that by putting this minus sign here already. And now I just subtract the way we subtracted before. 3 can't take from 1, so I'm going to borrow from the 4. It becomes a 3. That becomes an 11. 11 minus 3 is 8. 3 minus 2 is 1. Line up the decimal. 12 minus 8 is 4.18, which makes our final answer negative 4.18. When the second one is bigger than the first one, make it negative and then subtract by hand the way you're used to. Biggest minus smallest. Don't forget that minus sign. I'll leave you to play with 4, 5, and 6. If you need a hand with any of that, let me know. Let's take a look at some of these guys down here. I'm going to do 5 of these questions because it gets interesting. Multiplying decimals is slightly different. Multiplying decimals looks like this. If I have negative 2.3 times negative 8.1, I'm going to write this out by hand because that's what we got to do here. 2.3 times 8.1. Now, I'm not including the negatives here because, well, that's really just kind of an exercise we're going to do in our brain. If I have two negatives multiplying together, what's that going to give me? It's going to give me a positive result. And so do I have to label my negatives here? No, because negative 2.3 times negative 1.8, or sorry, negative 8.1 is the same as positive 2.3 times positive 8.1 because the result is going to be the same. When we have the double negative, we can make it a positive. Yeah. Is it emergency? Yeah, you can go off. Okay, so how do we multiply decimals? I've got this here. It's almost the same as multiplying multiple digit whole numbers. We take our first digit on the right and we multiply both of the things up top by it. So 1 times 3 is 3. 1 times 2 is 2. Now when I want to multiply by the 8 on the next line down, I put a 0 there to take away that place value that we've already dealt with. And now 8 times 3 is 24, so I put the 4 there, I carry the 2 up there. 8 times 2 is 16, 17, 18. And now we're going to add. 3 plus 0 is 3, 2 and 4 is 6, 8 and nothing is 8, 1 and 1 nothing is 1. Oh, that was harder to say than I thought it would be. But what do we do with the decimal places when we actually multiply? Because right now what I've written is that 2.3 times 8.1 is 1,863, which we know isn't true, Carson. What do I do? How? Why 2 spots? Yeah, so I've got 2 decimal places up here in the things that I'm multiplying together, 1 in each. So I move my decimal place in the answer over the same amount. 1, 2, boom, there it is. 18.63. Nice and easy, but it helps to review. Let's take a look at number 2, division with decimals. Division with decimals is an interesting little beast because division with decimals is a little bit weird. But writing division is the same as what? Other thing that we've talked about. Usually I say it the other way. Something is the same as division, but let's go the other way. Division is the same as what? Writing something as everyone's favorite F word in math, a fraction. When you have a division statement like this, I want to demonstrate what we do here by writing it as a fraction. So I've got 3.2 divided by 1.6. The thing that we're dividing by becomes our denominator. The thing that we're dividing is our numerator. So this is the same as negative 3.2 over 1.6. It's the same. Division and writing something as a fraction are equivalent. But this is terrible. We don't have decimals in denominators or numerators, so let's change that. We want to write this as an equivalent fraction with whole numbers in the numerator and denominator. And so what do I have to do? Yes, Carson. By doing what? By doing what? I can't just take them out. I have to have a mathematically valid reason for doing that. Multiplying by what, Matthias? You betcha. I want to multiply both of these by 10, and what does that do? Every time you it's just like the percentages. When we multiplied by 100, it moved the decimal to the right twice. Multiplying by 10 is going to move the decimal to the right once. It moves it, the powers of 10, move the decimal once for every 0 in the number. 100 has 2 zeros, it would move it twice. 10 has 1 0, it moves the decimal once. So this is going to make this question negative 32 over 16. Well, what's negative 32 over 16? It's negative 2. But the thing that I want you to notice, what I'm trying to demonstrate with this particular example, is this step right here. Taking our division statement and removing the decimals. It doesn't actually change the final result. 3.2 over 1.6 is the same as 32 over 16, which is the same as negative 2. All along, nothing had to change. So let's make it more interesting, shall we? Let's look at number 4. I have 0.05 divided by 0.1. I do not have the same number of decimal places in this question as I did in the previous question. And so that can change things ever so slightly. When I have something like this, which of the two do I most want to get the decimal away from? The thing I'm dividing or the thing I'm dividing by? The thing I'm dividing by. If we think about this as a long division statement, when I have long division, regularly we will say, okay, well, it doesn't go in perfectly, so I'm going to add a decimal, add a 0, bring it down. Then I'm going to add another 0, bring it down. Add another 0, bring it down. We regularly add decimals into the inside of a long division statement. The thing that's on the inside of the long division statement is this number right here. It's the first thing we've got. The place we don't want any decimals is right here. No decimals outside. This is what we're trying to avoid. And the number that ends up on the outside of a long division statement is the thing that we're dividing by right here. So we don't actually have to get rid of all of the decimal places everywhere. We just have to get rid of the decimal places in the divisor, the thing that we're dividing. So to do that, what am I going to multiply 0.1 by? 10, because I'm going to move the decimal once. So I'm going to multiply this guy by 10, and whatever I do to one, I have to do to the other. So this is going to become, it's going to move the decimal once, this is going to become 0.5 divided by 1. Oh, look, that's really pretty. Because what is dividing by 1? The same as doing nothing. Anything divided by 1 is just itself. So 0.5 divided by 1 is just 0.5, and we're done. By moving this thing around and getting that decimal out of there, we're actually left with what our answer needs to be. You don't have to, like in this one, it just happened to work out that we got rid of all of the decimal places everywhere, but over here, it didn't quite work out that way. Three more examples, and then I'm going to free you to play with some stuff. Here we go, number 5. We're going to bring bed mass into this. Here we go. B-E-D-M-A-S. Some of you guys would really benefit from writing out bed mass and then just like crossing them off as you go. So do I have any brackets in this question? Yes. Is there math going on inside those brackets? That's right, Carson. No. We have no exponents. Those are coming next chapter. Do I have division or multiplication? Yes, I have both. And when I have both, what do we do? Left to right. So let's do that, left to right. We're going to have negative 0.2 times 31. And here we're going to do it all longhand. So when you've got something that looks like this, what I'm going to recommend every time is that when you're multiplying longhand, you put the bigger number up top. So this is going to be 31 times 0.2. And because 0.2 is negative, my final result is going to be negative. So I'm going to force the negative down there, and now I'm going to multiply. 2 times 1 is 2. 2 times 3 is 6. And is 31 times 0.2 62? What do I have to do? The decimal point. I have one space to the right of the decimal here, so my answer needs one space to the right of the decimal. 31 times 0.2 is, well, times negative 0.2 is negative 6.2. So I've made my change here. I'm going to write this down. Negative 6.2 divided by negative 0.31. Well, I've got two negatives. I have a negative divided by a negative. That's going to make my final result positive, and so this is the same as 6.2 divided by 0.31. It's equivalent. So I'm going to drop both those minus signs. And now I want to get rid of decimal places. Where do I care about getting rid of decimal places? The thing I'm dividing by. So what do I have to multiply both of these by to get rid of this? 100, because I need to move it twice. I'm going to multiply by both of them by the same thing. So this is going to become 1, 2. That's going to become divided by 31. And this is going to go 1, 2. There's a space there, so we're going to add a 0. The question becomes 620 divided by 31. Now, if you don't, either way this is going to suck. You could set it up like long division, not suck. You could set it up as long division, or you can just kind of notice where this is going. Yes? You may. Write your name on the board. If I set it up as long division, 31 into 620, I still need to figure out how many times 31 goes into 62. Well, there's a kind of a nice little trick here. How many times does 30 go into 60? How many times does 1 go into 2? Oh, look, it's both 2. So we're going to put the 2 up there. 2 times 30 is 60. 2 times 1 is 2. So 31 goes into 62 twice. Add the 0, bring it down. How many times does 31 go into 0? Sorry? 31 goes into 0 how many times? 0 times. Toss the 0 up top. 0 times 31 is 0. Subtract the 0. We're done. Oh, look. 620 divided by 620 divided by 31 is positive 20. There's our answer. That's how I would demonstrate this without using a calculator. Gentlemen, you don't need to talk after everything I do. Questions about what I've done? Let's do one more, shall we? Actually, we're going to do 2 more. This one and then 1 more. There are no questions. Here we go. Let's write out BEDMAS again. B-E-D-M-A-S. BEDMAS says, what do I do first? B stands for brackets. Is there math in brackets? No. Done. No exponents. Is there division? Yes. Is there multiplication? Yes. Are they attached to each other by more multiplication and division? No. So I can do them they're separated by this addition statement here. So what I'm going to do is I'm going to do this side and this side at the same time and then we're going to add those two results together. Let's do it. Negative 2.1 times 3. Well, okay, so this is going to be 2.1. I'm going to put the thing with the, I shouldn't have said biggest. I want to put the thing with the most place values up top, and the thing with the least amount of place values at the bottom. That's negative. So because this is negative, my final result is going to be negative. 3 times 1 is 3. 3 times 2 is 6. It's negative, and I need to have the same number of decimal places in my answer as I do added up in all the decimal places here. There's 1 decimal place there, so there's 1 decimal place there. Negative 2.1 times 3 is negative 6.3. To that, I'm going to add whatever result I'm going to get here. 4.2 divided by negative 0.6. Well, to do that division, I'm going to multiply both of these numbers by what? Who said that? You're right. I want to move the decimal place here once, so I want to multiply this guy by 10. Whatever I do to one, I have to do to the other. It just so happens to work out that this is going to now become 42 divided by negative 6. I don't need to set this thing up for long division, because this is a times table you should know or be able to find easily on your multiplication tables. 42 divided by negative 6 is, it's not 7. It's negative 7. Because it's not 42 divided by 6, it's 42 divided by negative 6. And then this should be something you can add relatively easily. This one doesn't have any place value, so you're just going to take the 7 and the 6. What is negative 6 plus negative 7? Yes, Justice? It is negative 13, and that 0.3 comes along for the ride. So that is how I would model these BEDMAS kinds of questions without a calculator with decimals. It's less work, I think, than all that fraction stuff we were doing before. Here's what I'm going to get you to do. Flip the page. This page here is all fractions, this first one that shows up. This page here is optional. If you're struggling with fraction math, I would encourage you to do it. But if you're like, I nailed that quiz, I don't need to review none of this fraction math, skip it. Same thing on the next page, optional. Flip the page again. This top part, again, optional. I will provide you answers to these if you do them. If you got annihilated on that quiz I gave you, I would encourage you to try these. But this is what you must do. This is the non-optional homework, the bottom half of the page. Questions 2 and 3. As you notice, perhaps word problems are showing up. These word problems are not supposed to be overly involved. It's just getting you used to operating with a language in math. So what I want you to do before you do these questions is flip the page again. And we're going to look at 2 questions really quick off of here. Let's talk about number 1, shall we? This is going to be the irritating part for a whole bunch of you. I'm going to read it. Callie will be 43 years old in 13 years. How old is she now? The answer is obviously 30. I heard like 4 people say it. What I want you to be able to do, though, is not just write down the answer. What did you do mathematically in your head to get that value? You have to show me your work. Yeah, you took the age she's going to be. You took away the number of years it would have taken her to get there. 43 minus 13 is 30. It's not hard to do, but I absolutely have to see it or you're not going to get any credit for the questions. And Jacob's mad. Okay, let's slide over here to question 4. Deshaun spent $33.60 on batteries. If they cost $4.20 a pack, how many packs did he buy? How does anyone recall how you go about finding the number of packs of, or the number of objects of something given the price per object and the total amount of money spent? Alex, you divide what by what? Yeah, you divide the total amount spent by the cost per object. Now that's not very nice. So we're going to have to do, we're not going to calculate it, we're going to do this longhand, maybe. We'll do it longhand. The question is, what do I have to multiply by to make our life a little easier here? Do I have to multiply by 100? Are you just saying that because I asked the question? You want to multiply by 100 because you want to move the decimal over twice, right? Okay. Because we have a 0 here, is multiplying it twice or multiplying it once, it's still going to be a whole number, right? Because this is a 0 here. Now this was $4.25. That's a different question. Then you absolutely need to multiply by 100. But because this number ends in a 0, you don't have to move it all the way. You just have to get it to the 0. So if I multiply both of these by 10, thank you so much, Jacob, by the way, for doing that. Someone did that for me in the other class too. It was perfect. So I'm going to, instead of multiplying them both by 100, because this number ends in a 0, I'm just going to multiply by 10. It's going to move the decimal once in each case. And my question is going to become 336 divided by 42. This is still a bit of a doozy. Let's write it out longhand. 336, 42. 42 doesn't go into 32, so we still have to figure out what this goes into. But sometimes writing like this actually makes our life a little bit, organizes a little bit. At least it does in my head. So now this is the thing I hate in math the most. Students seem to love to do this all the time. I hate it. But here we go. We're going to do some guessing and checking. The packs have to be a whole number. You have to have a whole number of packs. Because you can't buy a partial pack of batteries. Because that means you went to Canadian Tire, ripped open a pack, stole some batteries from another pack, or just left them on the floor, and now you're going to, they don't do that. Canadian Tire doesn't like that. So, this is going to have to be a whole number. Let's make some guesses. I saw some fingers going up already. Your guess is 8. Why did you guess 8? But why? You have to have a good reason. It's called educated guessing. There is a good reason to guess 8. What is it? Okay. So we're looking at 42 into 336. One of the techniques that I've tried to demonstrate on the board when I'm going over like your quiz corrections is a thought process that looks like this. I don't know about 42 into 336, but I can make a reasonable guess for 4 into 33. 4 times what is going to get me pretty close to 33? That 8. So let's try 8. That is why I'm going to guess 8. Because it's going to get me, because I know that because 4 times 8 is 32, 40 times 8 is going to become 320. That's why I'm picking 8. So let's model this. So multiply by 8. 8 times 2 is 16. Carry the 1. 8 times 2 we've already said is 32 plus 1 is 33. Oh, look. It works. What you're going to have to do for me on this, the review, and on your guys' test next week is demonstrate for me what's going on in your head on the page. Because you're not getting a calculator for this. Okay, there's a lot of time left, and I'm done talking. So, what I'd like you to do is this. In addition to this page, let me freak you out here. There are 40 questions. You are not going to do them all. What I want you guys to do are questions number 1 to 24, multiples of 3. Just to make your life interesting. So I want you to do questions 3, 6, 9, 12, 15, 18, and 24. 3, 6, 9, 12, 18, 21, and 24. I always forget 21. Always. I go from 18 to 24 all the time. If you want extra practice, there are 20 questions, more word problems. I'm going to call it optional. And if you flip the page one more time, there's answers to those 20 optional questions. So I provide to you a key for this page here, this is what we're doing. Yes, put your name on the board. Okay, you've got a bunch of work to do. You got some decimal practice. I want you to do all of it. And then I want you to do multiples of 3 on the first 24 questions. I am around to help you. You can work on the whiteboards if you want. Otherwise, on your mark and say giver.